Okay. So there doesn't seem to be a question. Let's move on to the next one. So the next one is asking us to find the radius and the height, right? So radius and height of the right circular cylinder of the largest volume, right, that can be inscribed in a right circular cone with radius of 6 centimeters and a height of 10 centimeters. And also determine the maximum volume using, obviously, similar triangles. And they're telling us that we recall that the volume of a cone of a circular cylinder is equal to pi r squared times h, right? So that's very good information. Now let's try to see how we can adopt it. So what does a cone look like? Well, you guys know that a cone looks like something like this. And obviously from your engineering drawing class, you know that this line here is, it's not, it's a dotted line because you can't see that side. So now they're telling us that we can fit, right, in this cone, we can fit a circular cylinder, right? So if you could imagine a cylinder inside this cone, with the largest volume, so the largest possible cylinder that can fit inside the cone, right? So that's the one that we're fitting in there. So if you can think of a cylinder inside that cone that we can represent as such. Right, so if you could think of a cylinder there, maybe I should. Okay, wait. Let me use a different color so it doesn't confuse with the rest. So if we have our cone looking like this, and we have the inside cylinder looking something like this. Right, so obviously this is just a representation, and they're telling us that the cylinder, right, the cone, sorry, has a radius of 6. So the distance, right, from the center of the cone, which is somewhere here, to the side, so this distance here is given to us as 6 centimeters. So this distance is 6 centimeters. And we are given that the height of the cone is 10 centimeters. So this is 10. So now, if you were to project, right? So here I'm trying to draw the diagram in a sort of a 3D on a 2D page, right? So, but if you were to project this, right? If you were to project this against, if you can imagine this, the diagram that I just drew in 3D, and you were to project it and represent it in 2D, right? You would have something like this. So if you can imagine that the radius of the cylinder inside the cone is, let's call it R, right? So this distance here is R. Now, if you had to represent it in 2D, you'd have something like this. The bigger triangle would look something like this, with this being equal to 6 centimeters, because you're only projecting, so basically you're only considering one side of this cone, right? You're only considering let's say for example this right hand side here, and you're projecting it into a 2D page. Then you would have the inside cylinder, right? That's somewhere here with a radius of R, and you would have that the height, right? The height of the cylinder that we don't know, not the, yes, is equal to h, right? And you would have that this distance here between the top of the cylinder and the rest of the cone is just 10, right? 10 centimeters minus the height. So this is just 10 minus the height h, right? So we have that. And now if you use similar triangles as they told you to do, you have that 10, right? Which is the total height of the cone, divided by 6, which is the radius of the cone, is equal to 10 minus h, which is the height of the top part here, divided by the radius, right? Oh, that's what similar triangles tell you. And now this is equivalent to r being equal to 3/5, right? Multiplied by 10 minus h, right? So we have that. Now we have the volume. The question is asking us to find the radius and the height of the circular cylinder. So R and H for the small the cylinder inside the cone. So and you're also asked to find the maximum volume. Now, so we are given, right? So let's just make some room. And let's start with the maximum volume. So we're given that the volume V is equal to pi r squared times h, right? So pi r squared times h. And we know that using the relationship that we obtained from our similar triangles, we have that r is equal to 3/5 times 10 minus h, right? So you can replace it there. So pi stays the same because it's a constant, multiplied by 3 over 5 times 10 minus h, right, all squared, multiplied by h. Now we have the volume in terms of the height alone, right? So now V is equal to, if you solve this, you have 9 over 25 multiplied by pi multiplied into 100 minus 20 h squared plus h squared, or rather h cubed, because the h is multiplying in, so h cubed. And we know that the boundaries for h, the lower value is 0, and the highest value h can have is 10, because they're telling us that the maximum height of the cone is 10, right? So that is 10. So now that we have that, we can find sorry, just give me a minute. Right, so we can find we have the volume in terms of the height. Oh, obviously I made a mistake here, sorry, it's supposed to be 100h. So since we're looking for the maximum, right? Remember, when you're looking for a maximum, you take the derivative of the equation that is given to you. So you're looking for the maximum volume, so you take the derivative of the equation in terms of height, right? Which is this one. And when you do that, and you're looking for when the derivative is equal to 0, right? That would be your, when you're looking for your maximum values. And the derivative of the volume, right, is equal to, again, same thing, 9 over 25 pi multiplied into 100, right, derivative 100 minus 40, right, 40h, because it's 20 multiplied by the 2 that comes down, plus 3h squared. Right? And we want to know when this is equal to 0. And if you solve for this, right, because it's a quadratic equation, so if you solve for h, you'll find that there are two solutions. A solution when h is equal to 10 over 3, or h is equal to 10. Now, remember that we can clearly see from the diagram that 10 is, h is less than 10, right? So it could be equal to 10 at the maximum, but from what we can see in the diagram, h has to be smaller than 10 because remember h is the height of the cylinder inside the cone, right? So it's this distance here. And if the cone itself is 10 centimeters, and we know that the cylinder is fitting inside the cone, then whatever the height of the cylinder is, it has to be less than 10, right? For it to fit inside the cone, right? So we know that h is most likely not equal to 10. So we can ignore that one. But since we have 10 over 3, which is less than 10, we consider this other root here. So let's make some room. So knowing that, then we can replace the value of 10 over 3 into the original expression for v, right? So we have that v is equal to pi, right? So pi multiplied by 3 over 5 multiplied by 10 minus the height, which is 10 over 3, squared, so that is all squared, multiplied by 10 over 3, which is the height. And if you solve for this, you'll find that this is equal to 160 pi divided by 3. And this is your maximum volume, right? Now, why is it your maximum volume? Let's explain that. The maximum volume of what? The maximum volume of the cylinder inside the cone. So if you go back to the question, so the question is asking us, what are the values of the radius and the height of a cylinder, the maximum values of a cylinder that can fit inside this this cone here. Now we know that the cone is given to us once again with a height of 10 centimeters and a radius of 6 centimeters. So whatever the value of the radius and the height of the cylinder that is fitting inside the cone are, those values have to be less than these values that are given to us because it has to fit inside, right? So if we found, just like we did, we found two values of h, one value that is equal to 10 and another value that is equal to 10 over 3. Obviously, like we said, 10 over 3 makes more sense because 10 over 3 is less than 10, but also when h is equal to 10, it wouldn't make sense because then that is greater, or rather that is equal to the height, the total height of the cone, which is not possible because the cylinder has to squeeze into the cone, right? So it has to perfectly fit into the cone. And from the diagram, you can already see that the maximum really, there's a certain maximum height that the cylinder can have inside the cone for it to fit, right? So it touches both extremities of the cone, right? So since we know that it can't be 10, it has to be less than 10. We found the other root to be 10 over 3, so that's what we chose. So the volume that you find, the volume of the cylinder that you find when you have that height of 10 over 3, that is your maximum volume. So it's the maximum volume that the cylinder can have inside this cone with the measurements that are given, right? So if you know that now, And that's what is asking us to, it's asking us to find the largest volume. So the largest volume of cylinder that can fit inside the cone. So we need to find what is the radius and the height equivalent of that. We've already found the height, right? It's 10/3. Now we need to find the radius, but we have the relationship between the radius and the height, right? We have that r is equal to 3/5 multiplied by 10 minus h, right? We already know that the height, the maximum height is 10/3. So the maximum radius will therefore be 3/5 multiplied by 10 minus 10/3, which is equal to, if you do the calculation, you get 4 centimeters. So the maximum radius of the maximum cylinder, of the largest possible cylinder that can fit into this cone, is 4 centimeters. Right, so hopefully that makes sense. Any questions? All right. Okay. We'll have to stop here because we are running out of time. I have another meeting that I have to join now. But so we did quite a few. So what I will do is I will try to record myself. Let me stop here first.